Hello guys, welcome back to my channel, and those who are new to this channel, kindly make sure that you subscribe to this channel for the latest tech updates and the tech knowledge. And hope you all guys are doing really well. So today is day 10 of the 20 days of the statistics course, and today we're going to study about the binomial distribution and the Poisson distribution. Okay, so without any delay, let's just start the topic. So first one is our binomial distribution. Binomial distribution. So it is nothing but how many successes in a fixed number of trials. It is about how many successes we achieved in a fixed number of trials. Fixed number of trials. The second one is our binomial distribution, Poisson distribution. Okay, Poisson distribution. It is nothing but how many events occur in a fixed interval. How many events occur in a fixed interval. So think of it as like binomial, think of it as counting the successes, and think of Poisson as counting the occurrences over time or the space. Okay, talking about the binomial distribution first. So the binomial distribution models a situation where there are fixed number of trials. Each trial has two outcomes, either a success or a failure, and the probability of success remains the constant and the trials are independent. Okay, so let me write that for you so that you're not confused. Okay, talking about the binomial distribution first. Okay, so in this, like, we have there are fixed number of trials. Okay, so we have fixed number of trials, that is n is fixed. N is nothing but the trials. Okay, and each trial has two outcomes. So this each trial has two outcomes, either it is success or it is a failure. Okay, then the probability of success remains constant. This probability remains constant. Okay, probability remains constant, and the trials are independent. These are independent. For example, the number of heads in the 10 coin toss, the number of defective items in a sample, number of customers who click an ad out of the 100 viewers. So for if a player has 70% of chances of scoring and takes 10 shots, the binomial answers how many successful shots out of 10. So we are counting, successes in the binomial distribution. Okay, so we are basically counting successes. Now, talking about the second, which is the Poisson distribution, let's take a different color. Talking about the Poisson distribution. Okay, so Poisson distribution, which is basically the event rates, it models a situation where event occurs randomly and we measure them over time. So events occur randomly. Okay, events occur randomly and we measure them over time, area, or space. Measure them over either time or area or the space. Okay, then events happen independently and the average rate of occurrence is known as lambda. Average age of occurrence is known as lambda. Okay, for example, like I would like to give you the example of the Poisson distribution. The number of calls received per hour, the number of websites visits per minute, the number of accidents at a junction per month, and the number of emails received in a day. For example, like let me take an example, like okay, if a call center receives an average 5 calls per hour, okay, so the Poisson answers how many calls will arrive in the next hour. So we are basically counting the events, not successes. In this, we are counting the events. So basically, we are counting events. Okay, so the key difference between the binomial and the Poisson distribution, I would say, like what is counted in binomial distribution, the successes are counted, while in Poisson distribution events are counted, and the number of trials in the binomial distribution are fixed, while in the Poisson distribution it's not fixed, and the outcomes per trial, like binomial distribution only has two outcomes, either it's a success or a failure, and the Poisson we have like number of outcomes. Okay, and the key parameter in the binomial distribution are obviously n and the p, that is the trials, and the probability. And the Poisson, it is the average rate, that is denoted by the lambda. For example of the binomial distribution is heads in coin tosses, and Poisson it would be calls per hour. So the intuition behind these two are like the binomial asks how many times did I win out of the fixed attempts, and in Poisson distribution it asks like how many times did something happen in a fixed period. Talking about the data science relevance, the binomial distribution is used in the conversion rates. Okay, let's see where is all are these used. So I would say like binomial. It is used in the conversion rates, and it is used in A/B testing. Binomial distribution is also used in the classification outcomes. Talking about the Poisson distribution, the Poisson distribution is used in traffic modeling. It is also used in the demand forecasting, and it is used in the anomaly detection. Poison is often used when events are rare, but it's measurable over time. Okay, so this was all about the binomial distribution and the Poisson distribution. Hope you like the video, and if you like the content of the video, just like this video, subscribe my channel, and do not forget to hype my video so that I stay motivated. And meet you in the next day of the 20 days of the statistics course. Till then, bye bye.